before we put the part in the machine, we have sharp edges from the saw called burrs. We're going to use a file and we're going to knock the sharp edges over. Anytime you have the opportunity to deburr a part, to knock the edges off, take it. If you leave them on, well, it's a spot to get cut, and it's a spot to accidentally measure an edge that really shouldn't be there. So you lose accuracy. So got the burrs off this. This feels smooth. And you notice I didn't file it like this. I filed it at a 45 angle to the part, and I twisted the file. Now this takes a while to get that hand motion right. This is the skill you got to develop, but this makes the edge look a lot better and feel a lot smoother. There. So I'm going to go ahead and I'm going to put it in the chuck. Now this is an engine lathe. This is the handle. This is a 3-jaw chuck. It has 1, 2, 3 jaws. All 3 open and close when you at the same time when you twist this handle. I'm going to tighten it up. I'm going to put the chuck key back in the rack it came from. Do not leave the key in the chuck. This is dangerous. The machine can turn on, this chuck key flies out. Now, I know some of you are going to say, well, it won't turn on with the lid up, which in the case of this machine is true. But older lathes, of which there's tens of thousands of them out in the world, don't have that cover. So it's a good habit to get into is to always put the key back and leave it in the chuck. Now, next thing we're going to do is we're going to set center height on the tool. If you draw an imaginary line through the middle of this part, right in the center, that's the center of the tool, or center of the part. The tool has to be on that center line, on that line. It can't be above, it can't be below. Fortunately, the tailstock is at the same center line as the chuck, and this is the tailstock of the lathe. So what we did was we used a live center, which is this, make sure it was clean, slid it in, and this is a self-holding taper. It doesn't move. So what we're going to do is we're going to move the carriage using the Z-axis handle, which is this big one, over. X-axis diameter, we're going to move it in to get close to the tip. We're going to leave this handle alone, and all of these handles we're not going to touch. Now if you look, the tip of the tool here is way above that center. So I'm going to take this knurled knob right here and I'm going to run it up, which makes the tool lower. Now if the tool is below, I would run the knob down like that, which makes the tool much higher. I need it lower, so I'm going to lower it. And by eye, as best I can, I'm going to get the tip of that tool to be the same height as the tip of the center. And when I got it right there where I want, I'm going to move it around to the other position on the tool post, and I'm going to tighten it by pulling this handle back. Now if you notice, there's a wedge here. It's sticking up right now. Turn this handle, the wedge drops. That wedges this tool holder onto the tool post. Now it doesn't move. If I loosen it, it slides up and down. Tighten it, it stays put. If necessary, I'll move this tool post around as well. I want the face of the tool, show it over here, parallel to this surface here. And if you look down, they're pretty close. If they're not, that nut, take the wrench, loosen it up, and move it around as needed, back and forth as needed, keep it centered, and by eye, line it up parallel, and retighten. So crank up carriage, close. I'm going to turn the readout on. Twist E-stop, turn the machine on. Master power switch. This is the speed control. This works by low, medium, high. High range is orange, medium range is green, low range is blue. Now it's in medium. Now it's in high, or about to be in high. Now it's in high. If it doesn't want to go all the way, turn the chuck by hand. It'll line up the gears inside it. Now, high range, that's in the orange. This lever is lined up with the 612. I can move it over. Now it's on 885. Move it again. Now it's on 1800. Now it's on the medium range. I went from 1800 to 515. I'm going to move it back to high and back to 612. Do not ever pull these levers with the machine running. Make sure the chuck is off, it's not spinning. So, I got my RPM set at 612. I got the master power on. The E-stop is twisted out. Lights on. I got my tool tight. I got it lined up. I got height. So now what I can do, close the lid. Make sure no long sleeves, no jewelry, no watches. Safety glasses on. No open-toed shoes. If you're during the pandemic, you should be wearing a mask. I'm in here alone. So now what I'm going to do, draw the tool back. Around the other side. Actually, the other side. To turn the lathe on, make sure nothing's going to hit. Spin the chuck. Nothing's in the way, nothing's going to hit, because what you can do, you can run this tool in carriage so close that you can actually strike the chuck when it turns on. So be careful and watch that. So I'm good. This lever, up is reverse, over and down is forward. Now the lathe turns on. So I'm going to use the Z-axis handle, and I'm going to come up until I just touch the part. And you see the tool start to dig in and makes kind of a little circular impression on the face of the part. When I did this, I didn't crank away when I touched. A lot of students, they come up on the part real fast and they hit it, like I just did, and they get nervous and they back away. Don't back away, stay right there. Use the X-axis handle, the smaller one here, the medium one here, and go ahead and face into the part. And you'll face the center. Don't face past center, just go to center, and then face out. Okay, now one thing I forgot, as an aid to see what's going on, because aluminum is pretty bright, and whether it's cut or not, it looks about the same, I'm going to go ahead and I am going to lay out my work. Now, this is often referred to as bluing the work, because the original die was blue. I'm using just a plain old dry erase marker here, but it'll work. And obviously you do this with the machine off for safety reasons. And I'm doing this so that I can see where I'm marking the work with calipers, or where I hit it with the tool and machine some of it away. This makes it really obvious. So I'm going to set my tool for the length I want to cut. And I want to make this snout 750 thousandths long. So I set the caliper on 750. And this is easier when it's not in the chuck. But hopefully you guys can see that line I just drew right there. So what I'm going to do, come away, turn the machine on, and you can see the black dye on the face of the part. Normally, as I said, this would be blue. It's called bluing, or called laying out your work. And this is done so that you can mark your part with the dimensions that you would have when it was done, or the features it would have when it's done. And it's a visual aid. Now you can really see where I touched it with the tool. Scrape the black away, and it's a nice bright silver ring. Face out. Face back in, all the black's gone, I know I faced off and cleaned up the entire end of that part. Machining material from the end is called facing. So I'm going to go up here to my readout, and this measures position. Now, just because this has a number on it doesn't mean the number means anything. This was just turned on. It's not a real number. It's not valid. Now, the top number is diameter. The bottom number is length. Okay, so top is X, bottom is Z. I just faced the Z-axis, the length. I didn't change it after I faced it. It's this, right now the tool and the work are the same. So I can hit the diamond and zero it out. So I hit triangle, 0, enter. And now it's all zeros. So now what I can do is come over the side of the part. I'm going to turn it instead of face it. Turn it is removing from the length. So I came until I just touched the outside of the part, and I use the Z-axis handle and I crank in, turning the length, or turning the OD to diameter. And I'm being careful here. I don't want to go past that line, and I also don't want to run into the chuck. So every so often I'm going to look around and make sure everything's good. And I'm going to go to 740 thousandths. I'm going to back up. Now, a couple things here. I said 740, right? Well, the part's 750 and accidentally went to 747. Why did I go less than 750? Well, if you have a checking account, you don't want to go all the way to 0, right? And you certainly want to go past 0. Well, what happens here is, if I want this, every time I face in, I accidentally stop at a little different point. And I end up with a wall that looks like that. Well, that's not a good part. That's what I want. Straight snout, straight wall. So I'm going to leave this a little bit under, so I don't care if it looks like this. On the last pass, when I get the diameter, I'm going to turn it, and then I'm going to face out, and I'm going to clean that wall up. And the part will look like new money, as they say. So I have my face at 0, and I just turned diameter. I don't know what the size is, but I can find out. I can measure it. And that's exactly what I'm going to do. So the part is reading, and I'm reading this while it's on the part. I'm going to wiggle a little bit, push the thumb wheel down to close up on it. And it's reading 987 thousandths. Okay? Now I didn't crank diameter out, I was using Z-axis only. So 0.987, enter. And I can verify this by taking my Z-axis or X-axis handle, turning in a little bit, and my number gets smaller. That's the number I wanted, not the bottom one. Now if this moved some other way, like it had gotten larger, because I put negative in, I would just go back to 987 and reset it. So this machine is capable of a very heavy cut, much heavier depth of cut. In other words, how far the tool goes into the work with each pass than I feel comfortable as allowing students to do. So what I'm going to do is, I'm going to go for something smaller. So I'm going to take off 50 thousandths, 0.05. I was at 0.987, I subtract 50, I ended with 0.937. So I simply look, crank in, 937. Close the lid, out and down to turn it on. Now these strings come off, these chips come off, get really long and get nervous, just stop cranking for a second and they'll break. And then go back to cranking. Now don't look at the line you're cutting, look at the readout and go to 740. And back up. Go in another 50, so that would be 887. And don't worry about that last number. And turn some more. $837. Now I'm going to measure after this pass. I don't want to just machine down at 0.5 inches and think I have it right. I got to measure a bunch of times along the way. So what I do for this pass is I'm going to crank slower to get a better finish. Hopefully the camera shows the difference between the two finishes. Go to 740 again. I'm going to back up. I'm going to turn the machine off, and there's a brake to help slow it down if you're in a hurry. Now, word of caution about that: don't stomp on the brake. Just press down a little bit. Don't abuse it. So I'm getting 848. I should have 837. That's a little bit different. I go with the new number. Readouts are great time savers. They help you track position of the tool, but they're not really exact on a lathe. So don't trust them. Anytime you're machining, do not just measure and then take off a bunch of material and assume you're right. You have to measure along the way. The analogy I always give is, if I'm going to drive to Raleigh, I'm not going to get on the highway at this exit, set my odometer to 0, and drive 60 miles and take a right. Along the way, I'm going to see signs that say Raleigh 30 miles, Raleigh 15 miles. And as I get closer, the signs get closer together. The first one I don't see for 30 miles, but the second one I see after 15 more miles. The third one I might see after I go 5 miles, saying there's 10 miles to go. As I get even closer, they're every mile, then they're every half mile, and then it's, Raleigh 2 exits away, and then Raleigh next exit, and then Raleigh right here. So we do the same thing in machining. We never take off more than half of the material we have remaining without measuring. So this helps you pick up things like, I read my caliper wrong, or I wasn't holding the caliper right, or a tool moved and I didn't notice. Well, if the numbers keep coming out way off, that was 10 thousandths off. That's a little more than I like, but it's not horrible. But if that were 50 thousandths off, I'd be really concerned that something moved or I read something wrong. So what I'm going to do now, see all these chips? The machines are not running. So it's a great time to push them out of the way. Now, if you don't want to push them by hand, that's totally acceptable. You really shouldn't push them by hand. Use a paintbrush, which is usually called a chip brush in a machine shop because we don't use it for painting, or use a chip hook, which I'll show you what that is later in the semester. But it's important to get that stuff out of here because this chip is long and sharp, and if you leave them here, eventually the spinning chuck jaw is going to pick them up and it's going to throw them at you. So get them out of the way first, and they'll stick to close. So I'm going to go down to 800. I'm going to do it again. And I can feed pretty fast across the part because I'm just roughing it in. I'm just getting material out of the way. Okay, I'm down to 600 thousandths. I'm going to go ahead and I'm going to feed a little slower. I'm going to take a measurement after this pass. And I notice it's still cutting, so I'm going to go ahead and take another pass without changing anything. Back up. So it looks like I am at 592 thousandths. I'll go ahead and enter that into the readout. Take another 50. I'm going to take it down to 550. Measure it again. I'm getting 559 now. These numbers are varying a little bit. It's a little bit worrisome, but I already know that this type of tool will sometimes give trouble like that. And also, depending how much you take off and how many passes, it's going to vary a little bit more. So I'm not going to worry about it. I'm just going to take small cuts and see where I am each time. So I'm going to go ahead and remember I said don't take off more than half. Well, I'm at 559. I have 59 thousandths to go. I'll take off half or a little less. So rather do a bunch of fancy math, I'm just going to say it's 560. I'll go down to 530 and I'll measure again after I take a pass. Looks like 530. Now keep in mind, see it moving around? If you don't have the caliper tight against the work and at a right angle to the work, you're going to get different readings. The jaws aren't going to be closed all the way. So make sure to wiggle it and hold it at a right angle. So readout drifted a little bit, so I'm going to leave that exactly the way it is. And I'm going to take off 15 thousandths. About 513. We'll take off half. .506, 507. So this time I'm going to go to 500 on the nose. And I'm also going to face it. This time I'm going to go all the way to 750. And then I'm going to face out with the X-axis handle. And that leaves a nice clean shoulder. And there we go. There's that part of the part. So now we have to center drill it, flip it around, and face it off to length. Now to remove the live center from the tailstock, what we're going to do, one way, runs forward, other way, sucks the quill back into the tailstock. And when it hits bottom, there's a knockout inside that pushes the live center out of the machine. Okay. Now we're going to do, crank the carriage away, and we're going to turn it down to the lowest RPM. And we're going to knock the edge off the part. Now this is important, folks. This is a handle, this is a file. Do not use a file unless it has a handle. We're going to file in the lathe. If you do not feel comfortable doing this, don't. Take it out of the lathe and do it by hand. But I'm going to show you the proper way to do it in the machine. We're going to close the lid because it won't run without it. We're going to put it on the lowest setting. We're down here at 50 RPM. Blue range, lined up here, it's 50. We have a handle, we have a file. We're going to turn the machine on. Once again, we're going to make sure no loose jewelry, no long sleeves. We're going to hold both ends of the file, one by the handle, one by the tip. We're going to hold it at a 45-degree angle against the work, and we're going to slowly slide it forward. Now this is the dangerous part here, because I'm against the chuck, but I'm going very slow. I'm holding it at 45. You might not want to do that. You might want to just do this one only and do the other part out of the machine. Turn the machine off. Carriage back forward. And we're going to leave 3 or 4 inches between the part and the tool. And we're going to move the tool back on the diameter, and we're going to move back to high range. So now what we're going to do, make sure the taper's clean, and we're going to put the drill chuck in. Now the drill chuck doesn't want to seat. You have to run the quill out a certain distance for the drill chuck to seat because of that knockout slot. And you're going to find you're going to have to spin it, and eventually it'll pop in. And what's going on is there's a tang in the bottom that isn't there on the live center. And the tang has to line up with the drive slot inside. So now that that's seated, we go ahead and have a center drill. This is a regular drill, this is a center drill. This is made to drill a hole, this is made to start a hole. If you just push this against the part without a center drill run into it first, this will hit the surface and it'll walk around. The center drill hits the surface and it starts to dig right away, and it digs where you want it, hopefully. And it'll leave a cone behind that this will fall into and follow that path. So what we're going to do is we're going to chuck up on the center drill, making sure we get it in all 3 jaws. And use the key, and we're going to tighten it. Now, some people do this for some reason. They hold it by the teeth, and then they get their finger caught inside there. No, hold it up here. Don't hold it like this. Don't hold it like this. Hold it up here. And you hold a snake by a tail, right? So there you go. Slide this forward. If it doesn't slide, this handle, there's 2 handles on here. One of them, the smaller one, locks the quill in the housing of the tailstock. That releases it. This long one locks the quill, or sorry, the tailstock to the bed of the machine. So loosen that up, push it down, close as we can. Tighten it. And we're going to go ahead and we're going to run the tool in. Now this needs a little bit of oil. Center drills lead a really hard life and they break off if you don't take care of them. You got to oil a center drill to keep it from breaking off in the work.
Okay.
So put a little oil on it. Close the lid. Turn the machine on. Everything's clear and nothing's going to hit. And we go ahead and we crank in the center. Be careful not to ram into the work with it, and don't force it. Let it cut. If it feels like you're forcing it, stop. Back up. To back up, turn it reverse. Forward again, a little more. I'm going to back up. Now if you look at that hole, you're going to see a cone at the end. That's what you want, because a center drill is a short section of straight and then a cone. The cone is what actually centers everything up. Make sure to have a cone in the work. Now you don't want to go past the cone and go into the straight body behind it, because that doesn't do any good. So I'm going to go ahead and I'm going to run the quill back. Stick the drill in. I need to move the tailstock back a little more. A little oil will not hurt. Now, as the drill goes deeper, the path for chips out gets longer. The chips will start to jam up and you'll feel resistance on the handle. So every so often, the resistance goes up, or just because, run the drill back out, give a little oil, clear the chips off, and run it back in. If chips stop coming out, back up, because you're packing the chips in and you might break the drill. Now at some point, it'll get real easy. You drilled through and that's what just happens. Turn the machine off, loosen the tailstock, slide it back out of the way. Use my chip brush, push all the chips off the drill bit. Not my fingers, because they're hot and they're sharp. And it's a good time to go ahead and get some of the surplus stuff out of the way. Now, there. I got about half the remaining part in the chuck. Tighten it up. I'm going to do the same thing as I did before. Be careful that I'm not going to run into anything but the part. Come against the face, see that circular groove? And I'm going to go ahead and I'm going to face it off. Turn the machine off. And I'm going to go ahead and I'm going to measure from the face of the part that I originally cut to the face I just cleaned up, and I'm reading 1.795 inches. So that's Z-axis. .795, and remember that number. I'm going to crank in about 10,000, so 785, and it gets smaller. If it didn't, I would go back to 795 and change positive to negative, or negative to positive, but we're good. So 785. Face it off. Turn it off. I'm going to remeasure. Now you notice I didn't take the part out of the machine. If I take this part out, I lost my location. So I leave it in there. Now, what happens if I were to crank this away and measure? Well, if I measure right now, I have the length of the part, which is 1.7, it's like 65. So it came off a little different than I was expecting, but I'm gonna live with it. I'm reading 2.4. That's the distance between the front of the part now and that gap plus the part. If I change this to a new reading, I'm going to get a different length of part. So you can't move stuff around after you cut. You have to measure and enter that reading. So I'm going to go back to 1.765 or such. I'm going to cut again and see where I am. And that's why you sneak up on your work. I have 1.764 on length, but my part came out 1.745. Well, what happened? Well, I was at 1.787. I went down to what, 77, something like that? And then I measured it and I came up with 10 thousandths less. Okay? And then I moved it away, and then I moved it back, and I went to 1.765, not 75. But I had a lower reading, and then I took more. See a lot of numbers, they don't all line up. This is why you don't crank away. This is why you always take off half and keep remeasuring. I didn't do that. I did that intentionally. I'm going to show you what happens when you don't. But if this part was correct, I'd go ahead and I'd knock the burrs off the edge, clean up, and I'd be done. So what I'm going to do is I'm going to go ahead and take the part out. I'm going to pretend everything's good. I'm going to deburr it by hand. Now when I do this shoulder, I'm careful not to hit that snout with the file. Working with a file takes a lot of practice to make it look right and not do any damage. But there you go. Faced off, faced, holes all the way through, shoulder's done, snout's done. So I would go ahead and I would inspect this part now. And yeah, it's coming out about 4 thousandths smaller than it should. I bet if I wiggle this, it'll be a little more than that. Yeah, 5 thousandths. So, diameter's right on. Length is right on. Now, if I measure this, it'll come out a little small. Because remember, we're working with a length here. This is correct. This is short. It's got to go somewhere, so that's where it's going from. But there's a part. So now, the part's done. We got to clean the machine. So we're going to push in the e-stop so the machine cannot turn on. We're always going to assume it can turn on, just for safety reasons. So now we're going to go ahead and we're going to take our brush and we're going to brush off all the chips. And we're going to do a good job of this. The cleaner you keep the machine, the easier it is to clean, the easier it is to keep it clean, the easier it stays clean. We're not going to use an air hose. Air hoses cause damage on machines because they blow the chips into the between the moving parts. Take the tool out. Brush all that clean. The tool goes back in the box. The center drill and the drill bit go back in their respective boxes. The drill chuck, put the key in the chuck out, it goes back in its box. And remember to put your file and your caliper back in your student box. that we can keep track of all this stuff. And I'm going to push all the chips down into the chip pan. I'm going to crank the carriage down. Get underneath the carriage, all the parts of the lathe. Going to get behind it, going to get the splash guard, and I'm also going to get a broom, and I'm going to get the floor, because there's going to be chips on the floor, and there's going to be chips on the floor on the other side of the machine as well. Also, walk around the back side of the machine and get the other areas. There's areas you're not going to see from the front. All the chips are down in the chip pan. This lifts out, and you can grab a dustpan and scoop everything out, put it into the trash can with wheels. The ones without wheels are for trash. The ones with wheels are meant for chips, and we'll roll it over to the dumpster and throw it in the metal dumpster. Trash does not go in the chip buckets. Just chips. If you throw trash in, it reduces the value of the scrap.